Two themes, actually, two themes that we're going to drill down on now because we have exactly the right person to give our first keynote. So the obvious one of inward investment, because we're hearing now from very much a global company, but also batteries mentioned and mentioned repeatedly. I should say when I was growing up near the town of Bridgewater when I was a boy, it was chiefly famous for the smell of the sellotape factory. It is now famous for much more than that, if indeed the sellotape factory is still there, which I doubt it actually is. So, Agratas, the company that is transforming that place, but also potentially has a huge role, a more wide role in this country and indeed in other countries as well. So, our first keynote of the day is from the Chief Procurement Officer of Agratas. Please welcome to the stage Karthik Selvan.
Thank you, James. All right. Good morning, everybody. My name is Karthik Selvan. I am the Chief Procurement Officer for Agratas. And today, I'm going to walk you through the realities of building a gigafactory here in the UK, building a resilient gigafactory here in the UK. And my attempt is to give you a visceral feel of what it really takes to build this factory, an advanced manufacturing facility right here in the UK. Before I do that, I want to thank my colleagues at SMMT for giving me this wonderful opportunity. Let me start off with what Agratas is trying to build. We want to build not just a battery manufacturing facility. We want to create infrastructure. We want to create infrastructure that enables clean mobility, stronger energy storage, and creates an ecosystem for our supply base to succeed at scale. What you see over here is how our footprints are shaping in two important geographies, one in the UK and one in India. Our gigafactory in the UK is located in the southwest part of UK in Bridgewater. Our R&D laboratory that is fully functional is located in Oxford, and I'll talk more about it in my later slides. We are building a gigafactory also in the UK at exactly the same time in the western part of India, and we have a fully functional state-of-the-art R&D laboratory in Bangalore. Now let me take a few moments to share with you a story. The Tata Group's foray into the energy ecosystem traces its roots back to the early 1900s. Tata Group was the first company to set up a large-scale hydroelectric power station in the western part of India that actually supplied clean energy into the city of Mumbai. Now, I'm from the city of Mumbai, so it's very personal. The city of Mumbai then had a burgeoning textile industry. However, this industry was battered with extremely erratic electric supply, costly electric supply, because it relied heavily on imported coal. So with the arrival of hydroelectric power station, this thing completely transformed the textile industry. The textile industry then started flourishing. You saw the costs going down, and they had access to this cheap and clean energy. And eventually, Mumbai came to be called the Manchester of the East. So we are very proud to be part of the Tata Group, because with that, it brings the foundation of trust, it brings the foundation of integrity, and the foundation of patient capital. So we are not here just to make batteries or build capacity, but we are here to build capability. Some facts and figures about the factory that we are building here in Somerset, Bridgewater. As you can see, the factory itself sits on a site that's 308 acres in size. We'll have 3 manufacturing plants when fully completed. Work is continuing on building number one, you look at the physical dimensions of building number one. That's immense in size. It's about 600 meters long, it's 165 meters wide, and 35 meters high at the highest point. It's a massive structure. It's expected to produce anywhere between 9 to 12 million prismatic cells a year. And when all of this factory is operational, it will create a direct employment of about 4,000 people. This gives you a bird's eye view of the 2 gigafactories that we are building. Now, Agratas is one of the few companies in the world that's building 2 gigafactories in 2 different geographies at exactly the same time. Call it what you want. There aren't too many companies doing that. The one to the left is the gigafactory that we are building in the western part of India in Gujarat. The one to the right is the one we have in Bridgewater. As you can see, work is progressing in both these gigafactories. We have the wall cladding done, the roofing done. The one in India starts with all of the MEP, that's the mechanicals, the electricals, and the plumbing stuff being installed with the equipment due to arrive in the next couple of weeks. From an operational standpoint, we have staggered the commissioning of these 2 plants. So we've commissioned the plant in India first. 6 months later, you end up commissioning the plant in the UK. Why do we do that? We do that so the lessons learned while commissioning one plant can be deployed to the plant in UK as well. Now, this spans just beyond process. It helps span capability build out across people. It helps us optimize process parameters. It helps us deploy our technology stacks, and more importantly, fine-tune material interfaces between both locations. Now, no gigafactory can be truly resilient, and we spoke about supply chain resilience as well. No supply chain can be resilient either without building deep in-house R&D capabilities. To this effect, we are building 2 state-of-the-art laboratories that's functional at the moment. One in Oxford. The one in Oxford is geared to focus on fundamental chemistry research. And the idea of doing that is to carve out of future cell roadmaps. The one in Bangalore focuses more on rapid prototyping, on design validation, material validation, process validation, and so on and so forth. But what really differentiates our approach is how we integrate this capability into execution. So we have a pilot line that is co-located with the manufacturing facility, implying the lessons learned from the lab can very easily be carried over into a production environment. But more importantly, as we scale up our production line, our pilot lines serve the purpose of fine-tuning our operational parameters, locking in process windows, and de-risking a scale-up. A big reason for your cost overruns is the time required for you to scale up. So now I want to show you a quick video of the beautiful structure that's coming up in the southwestern part of UK. So that's the massive, wonderful structure that's being built. So when you drive across M5, if you see this structure, it'll be grand, it'll be imposing, and it's a very proud feeling because this is going to transform the lives of people for generations to come. Now that I showed you how it looks outside, I'll give you a sneak preview of how a gigafactory looks inside. Typically, when I look at the process equipment inside the gigafactory, I don't look at it as one single linear line. It is technically three distinct zones that is tightly integrated with each other to what I call as the production heart. So your process equipment is essentially the production heart of your factory. Now, if you step back and look at this system, this is massive. The equipment itself spans more than half a kilometer from end to end. It arrives in 1,000 containers, and that is just one line. So you can imagine the amount of sequencing that needs to be planned for. And more importantly, this is an extremely high precision, high throughput environment. The precision at scale is exceptional. In fact, it can be compared to a semiconductor industry. When you look at a semiconductor industry, when you make your semiconductor wafer, it's typically 300 mm in diameter, and you're maintaining a 1 to 2 micron tolerance on the thickness. Likewise, when you're building a battery electrode, you're maintaining a target thickness of 80 microns to 100 microns, and your tolerance is within 1 to 2 microns. But now imagine you're trying to maintain this tolerance over an electrode roll that's 2 kilometers long. So it's semiconductor precision, not over 300 millimeters, but over kilometers. And that's a big challenge. The other aspect when you look at process equipment, when you design your gigafactory, you have to be cognizant of the fact that many of these technologies can be prone to certain type of technology restrictions and trade restrictions. So it's very important when you make your plans, you need to have a robust framework. How are you going to source the equipment? How are you going to install this equipment? You're talking about more than $1 billion in equipment. How are you going to commission the equipment? How are you going to service the equipment over the course of next 15 years? Do you even have access to the source codes for the equipment if you want to make changes to the equipment? So you need to make sure that all of these things are considered in the design of your factory if you truly want your factory to be resilient for the next 15 years. Here, I want to show you the complexity of running a gigafactory. Most people tend to look at a gigafactory in isolation, which means you look at it as a building, and then you look at it as equipment inside the building, people working on the equipment, and all your mechanical, electrical, plumbing stuff acting as a support system. The reality is, a gigafactory is nothing but a single, integral, high-precision operating system in which all of these four things need to come together precisely. So let me talk about the process equipment. The way I like to look at it is like a living system. So equipment is your production heart. But this equipment itself is maintained in a controlled environment. You have this equipment which uses massive amount of energy. You need to maintain an ultra-dry environment within the operating space, which then calls for energy infrastructure, it calls for an HVAC system, it calls for humidity control, it calls for fire protection systems. In a sense, your MEP begins acting as a vascular system. To give you an idea of the complexity, a gigafactory has more than 500 kilometers of piping inside. It has more than 600 kilometers of wiring inside. And if your MEP system is not stable, it's going to negatively impact the yields that come out from your process equipment. So you have the process equipment, you have the layer called the MEP controlling the process equipment, And around that is built your gigafactory. And in my previous slide, I mentioned that precision is exceptional. You're talking about precision which is more than a semiconductor factory, which means now the factory itself, the shell of the factory itself, starts acting as a precision instrument because you have to have exceptionally flat flooring. Last but not the least, your people are acting as the operating intelligence. When all of these four things come together and they are in perfect symphony, is when you're able to achieve your yields, your maximum uptimes, but more importantly, predictable performance. So the next time you think of a gigafactory, literally look at it as a living system. Your production equipment is your heart, your MEP is your vascular system, your structure is the muscular system, and people are your operating intelligence or the brain. So what is the takeaway in terms of building a resilient gigafactory? So number one, if there's a single takeaway that I want you to have is most gigafactories do not fail on account of technology. They fail because of lack of proper integration. The integration between people, MEP, the structure, and the process itself. But talking about the gigafactory, the construction of the gigafactory, let me share some statistics with you. If I were to build a gigafactory in China, it would take me about 12 to 18 months long. If I do the same thing in India, it takes me about 24 to 36 months in duration. And if I do that in the UK, it takes me 36 to 48 months, given the industrial landscape. And all of this costs money. So if I were to build a gigafactory in China, and I baseline it, and let's say that's X, when you build a gigafactory in India, you're looking at 1.2 to 1.4 of X. When I build the exact same gigafactory in the UK, it goes anywhere between 3X and 4X. And the big question is, how do you control these costs? You've got to have laser focus on your costs because you already have that much of a disadvantage. So the way you sequence your activities is super critical because I learned here there's something called as prelims, and then it just adds on and adds on and adds on. The second aspect, when you start building a gigafactory, you need to make sure that the envelope parameters of your building are frozen before you start construction. The number one reason for cost overruns is any changes to your structure after you start construction. So try to avoid that. Number three, the nature of the contractor industry in the UK is something that warrants a completely different session and discussion. Okay. I'll just put it this way. In the UK, there are contractors that are very good at heavy civil engineering, and then you have contractors that are very good at process, but very few contractors that are very good at integration. Remember, gigafactory is unique because you're civil engineering heavy, you're process heavy, and you have to integrate these two. The third aspect, you have to treat your grid timelines as strategic infrastructure and not a project-level issue. In the context of UK, this becomes absolutely critical because this will be in your critical path. The second aspect is sustainability. You cannot look at sustainability as an overlay for a gigafactory. It becomes a design constraint right from day zero. What do I mean by that? Any changes that you make to your site layout, to your energy supply, to your asset design, has long-term ramifications on environmental goals. If you look at our two factories, these are designed to maximize the use of renewable energy. We spoke about energy. The cost of energy in China is X, in India is X, Spain is 1.6x, UK is 2.3x. And for a gigafactory that is so energy hungry, this is your biggest operational expense. The second, we have also ensured that when we designed our asset, it is flexible and it is resilient to accommodate any future battery technology changes, which means our equipment is fungible. And that is important because it increases the shelf life of your massive structure. And that optimizes our carbon footprint from cradle to grave. Third, you've got to invest in your people because it's tricky. You can import equipment, you can't import people. Hopefully not, or yes, whichever way. But you can't import people. That's the right thing. Now, here's the catch. Therefore, you need to start training people 2 to 3 years before the start of your gigafactory. As Agratas, we don't use a singular approach. We have an integrated approach to training. And some of my colleagues are seated right here. We end up working with local communities, local colleges, especially with folks from the STEM side, in order to impart training. We have access to in-house training, and we also have access to our external partners that are able to give us on-hand training. And last, I would like to spend a few minutes talking about developing midstream material capability on the raw material on the supply chain side. You cannot have a resilient gigafactory if you do not have a resilient supply chain. Typically, the cell assembly is what you call the most visible and the headline part of a gigafactory operations. But every cell is only secure to the extent of the raw material that goes inside. And in this particular case, we talk about the active materials, the anode material and the cathode material. The cathode material receives a lot of emphasis given its value as a percentage to the cell. But I can also tell you that it is the anode that tends to be a lot more geopolitically vulnerable. So if I want to break supply chains, the likelihood of me targeting cathode material is in fact a lot lower. I would actually target the anode material. So think of it this way. You have mines all over the world, in North America, South America, Northern Europe, Asia, Australia. You have cell assembly plants coming up here in the UK and Europe. But all of things that happen midstream, so it's the refining, it's the precursor, it's the active material, is largely missing. It's all locked up in Asia. The uncomfortable truth for UK and Europe is that this capability is just beginning to evolve, and that is where the timing of the policy that Mike referred to is so absolutely critical. The rule of origin policy promotes local manufacturing, but it assumes the capability, aka midstream capability, is actually available. Now, if you introduce the policy before it's really available, you end up putting tariffs on the very industry that you're trying to protect. So the takeaway is very simple. A resilient gigafactory isn't just an assembly hall. It's actually an integrated material capability, which means the UK needs to have a trade policy that allows the gestation of the capability before the rule of origin comes in and bites you. With that, I'd like to finish my speech. Thank you very much.
Thank you, Karthik.